Hi, we are happy to present the paper Dino-v2 meets text, a unified framework for image and pixel level vision language alignment. Self-supervised visual foundation models produce powerful embeddings, which, however, are not readily aligned with language. Alternatively, clip-like methods train from scratch to align image and text encoders, however, focusing on the global alignment only. Our method, dino.txt, learns to align a trained text encoder to frozen Dino-v2 vision encoder in a lead fashion, therefore reducing training costs. We also propose a strategy to obtain both image and patch level alignment properties. So let's start. Let's start with clip. In order to obtain image and text alignment, popular strategy clip consists in training from scratch text and vision encoders with a contrastive loss. In particular, the global CLS is aligned to the text embedding. This strategy provides zero-shot image classification properties. Alternatively, LIT, which stands for Locked Image Tuning, reuses a pre-trained vision encoder. The image encoder is kept frozen to reduce training costs and also preserve the learned visual features. The text tower is trained from scratch as in a regular clip model. If LIT reduces drastically the costs of training, it still does not address the lack of patch level feature alignment. In order to obtain dense, therefore patch level alignment, methods like ClipEye have proposed to use the average of the patches to be aligned with the text embedding. However, doing so compromises the beloved global zero-shot classification quality of the alignment. With our method, dino.txt, we propose to align both the CLS and the average of the patches to the text embedding. In particular, we simply concatenate the two embeddings, providing us a single descriptor, which is aligned to the text. With this simple strategy, we learn to align both image and patch level representations. Additionally, we add a two-block adapter on top of the frozen encoder in order to further improve the alignment. With this strategy, we are able to perform at inference time both classification and segmentation with no adaptation of the model. So let's consider this image and a set of queries. For the classification task, we can use a concatenation of the CLS and the patch average of the vision encoder and compare it to the text embeddings. We apply softmax to select the best corresponding text query. Now, for the segmentation, we use directly the end patches, which are produced by the final adapter of the vision encoder, and we compare those against the corresponding part in the text embedding. We ignore the CLS part of the descriptors, as we observed that it mainly described the majority class. We then apply softmax to produce the map shown here. Now for training, we use a large dataset composed of weakly aligned image caption pairs. In order to mitigate the long-tail distribution of the dataset, it is possible to apply a curation strategy which balances concepts. Typically, such curation has been performed on the text modality. However, image and captions are not always well aligned, and therefore the text-based rebalancing might lead to unbalanced visual concepts. In this work, we propose to leverage both modalities and apply the text-based curation proposed in MetaClip, as well as the visual curation strategy of Vo et al. We finally take the intersection of both outputs to create our final selection, and we observe that best performances are obtained when using this intersection. Dino.txt is trained efficiently and only requires 19 hours to reach SOTA on ImageNet. As a point of comparison, Clip requires 110 hours to obtain 79% when we obtain 81.4. Moreover, with our training, it is possible to fit big batches. With our strategy, both the CLS and the patch embeddings are aligned with the text, as we have seen, and therefore allow us to obtain good segmentation with no additional tricks or model adaptation. And those are typical results that you can obtain with our method dino.txt. So thank you all, and if you have any question, please come and see us at the poster.